Hello, ladies and gentlemen. Welcome back to part 3 of the lesson on 5.2 solutions. Let's get started. I hope you guys had a nice little break. Interesting. Where did it go? I'm going to have to stop this. No, I don't have to. I can keep going. Yay, I found it. All right, so this is where we stopped talking about the solubility of gases. It is just the opposite of liquids, where if you increase the temperature, the solubility of gases decrease. Now, solubility versus temperatures. You guys have this graph on your assignment, and I would consider this the literacy portion of your assignment. So part of science literacy is being able to read a graph and deriving meaning out of that. You got to read everything from this graph, from the titles to the tiny little captions at the bottom if it has captions. So the title of this graph is Solubilities as a Function of Temperature. So what does that mean? Well, let's take a look at the y-axis. The y-axis is over here, if you guys forgot. This y-axis is reserved for the solubility. And if you forgot what solubility means, it means the amount of solute dissolved in the solvent. And in this case, remember, we got the universal solvent, water. It's for the solubility, it's the amount, the grams of solute for every 100 grams of water. The x-axis down here will be the temperature. And if you guys take a look, we've got 5 substances, 5 compounds. So each of these 5 compounds has its own specific solubility curve. Okay. Now the solubility curve shows the amount of solute that can be dissolved in 100 grams of water at increasing temperature. Okay. In general, if you take a look at this, in general, the solubility in the water increases as temperature increases. It happens except for one compound, this compound here. This compound shows a decrease in solubility. This compound, if you start off with 0 degrees temperature here, it actually decreases. You see the slope going down as the temperature increases. It's just a really weird compound here. Ce2SO34, otherwise known as cerium-3 sulfate. But the other compounds, in general, they are increasing as the temperature increases. We've got NaCl over here, sodium chloride. This sodium chloride shows the least amount of change in solubility from 0 degrees to 100 degrees. How do I know that it has the least amount of change? Take a look at the slope. It's practically flat compared to the slopes of KCl, potassium chloride, and potassium chlorate, and also calcium chloride. These other 3 substances, they've got a higher slope. That higher slope, that increase in slope, also means an increase in speed, the rate. The substance that has the greatest solubility at 10 degrees Celsius, let's take a look at 10 degrees Celsius. Let's take a look. The one with the greatest solubility, that one's practically flat. We already decided it's the slowest rate. This one's a little bit higher. This one's almost, but later on when it becomes even hotter, that's when the slope increases. It's what we call an exponential curve. But if you take a look at this one looks like it's got the biggest slope compared to all of them, right at 10 degrees. Okay, so the substance with the greatest solubility out of all of these has got to be this compound, CaCl2, calcium chloride. The maximum amount of potassium chloride that can be dissolved in 100 grams of water at 80 degrees Celsius over here. So if you guys ever want to figure out how to what the maximum amount is with all of these at a specific temperature, you just locate the temperature and find where that KCl ends up as, and then just look to the left over here. Not completely 50 grams, maybe around 51 grams. So potassium chloride at 80 degrees means that you can dissolve about 51 grams of potassium chloride at an 80-degree temperature. That is the maximum amount that potassium chloride can be dissolved. Okay? But what about another one like sodium chloride over here? So the maximum amount of sodium chloride at 80 degrees that is correct, at around 40 grams. So sodium chloride, you can only dissolve only 40 grams of sodium chloride at 80 degrees Celsius, but potassium chloride, you can dissolve more of that, around 51 grams. So which one has the greater solubility? Potassium chloride does. Okay. So let's take a look at potassium chlorate over here. Potassium chlorate. Now, let's see, potassium chlorate, and let's look at a random temperature. Say 90 degrees. 90 degrees of for potassium chlorate. Now, let's take a look over here. The maximum amount for potassium chlorate at 90 degrees will be 40 grams. You can only dissolve 40 grams of this potassium chlorate at 90 degrees. Now, say you are given 60 grams of potassium chlorate, but you know that only 40 grams of that will dissolve at 90 degrees. You're going to have a leftover of 20 grams that will not dissolve. Okay? The only way for the excess 20 grams that can dissolve is if you increase the temperature. Now, when a solution can no longer dissolve its solutes, that's what's considered a saturated solution. So a solution is classified as saturated when it can no longer dissolve anymore at that specific temperature. Now, this solubility curve, it suggests that we can safely suggest that most of these compounds are polar substances. We can suggest that they're polar substances because water, if they're dissolved in water, water is a polar substance.